Picture a late afternoon at the end of the Cretaceous. The forests are still green. Herds of plant-eating dinosaurs are still moving across the warm, humid land. Predators are still doing what they've done for tens of millions of years, ruling the world around them. Nothing about it looks like an empire on the verge of collapse. And then, in a stretch of geological time so short it was almost a blink, everything changed. Around 66 million years ago, a mass extinction event wiped out about 75% of all species on Earth. Over decades of research, scientists have followed the clues left behind in rock layers, dust, and fossils to piece together this ancient mystery. So how did dinosaurs really disappear? Was the killer an asteroid from space? The massive volcanic eruptions of the Deccan Traps? Or the combined force of both disasters? The first rulers. If we rewind the clock to more than 230 million years ago, back to the late Triassic period, we'd meet the earliest ancestors of the dinosaurs on the supercontinent Pangaea. Back then, Earth was hotter and drier than it is today, and all the continents were still joined together in one enormous landmass. From small, quick-moving reptiles that walked on two legs, dinosaurs slowly evolved into all kinds of different forms, kicking off a golden age that would last for more than 170 million years. And here's the really interesting part. Dinosaurs were never some lucky group of animals that just happened to be in the right place at the right time. They were actually one of the most successful groups of creatures ever to live on this planet. They handled shifting climates, adapted as the continents broke apart, and survived environmental upheavals across multiple geological eras. If you classify them by hip structure, dinosaurs are usually divided into two major branches: Saurischia, or lizard-hipped dinosaurs, and Ornithischia, or bird-hipped dinosaurs. Yeah, that sounds a little technical, but the simple version is this. From those two branches, nature built an entire dinosaur universe. Wildly diverse, incredibly resilient, and way more impressive than most of us realize. The notorious hunters, or the gentle giants? When people think of Saurischia, the first name that usually comes up is Tyrannosaurus rex. And fair enough, T-Rex is basically the poster child for prehistoric ferocity. A crushing bite, dagger-like teeth, an incredible sense of smell, and the kind of predator that made everything else think twice. But Saurischia wasn't just packed with ruthless hunters. This same branch also gave us giant sauropods like Brachiosaurus and Argentinosaurus, the gentle giants of the dinosaur world, able to reach the tops of trees just by lifting their necks. Ornithischians, on the other hand, were more like the all-star lineup of famous plant eaters. You've got Stegosaurus with its plates, Ankylosaurus built like a living tank, and Triceratops with its striking horns and massive frill. They may look calmer at first glance, but these animals were masters of defense, thriving for tens of millions of years. The golden age of dinosaurs. By the Jurassic period, as Pangaea began splitting into smaller continents, dinosaurs entered their golden age. Continental drift might sound like dry geology stuff, but it actually created all kinds of new habitats. And every time new land opened up, dinosaurs adapted in their own way, making the prehistoric world even richer and more diverse. The climate was warm, forests were thriving, and food was everywhere. Basically a paradise for plant eaters. And wherever there's prey, predators are never far behind. From Allosaurus in the Jurassic to Velociraptor, Tyrannosaurus, and Spinosaurus in the Cretaceous, meat-eating dinosaurs became more and more specialized, climbing their way to the top of the food chain. What makes this even more fascinating is that right up until the very end of the Cretaceous, Earth still didn't look like a world on the verge of collapse. Forests were still green, oceans were still full of life, and on land, dinosaurs were still in charge. And that's exactly why what happened next has haunted scientists for so long. The extinction event, the tragedy that ended a golden age. Around 66 million years ago, Earth crossed the KPG boundary and went through a mass extinction that wiped out about 75% of all species. It wasn't just the non-avian dinosaurs that disappeared. Other groups vanished too, including pterosaurs, large marine reptiles, and countless small marine organisms that had formed the foundation of entire ecosystems. What makes this event so striking is that it doesn't look like the ending of a world that had been dying for ages. The fossil record suggests that right before the extinction, dinosaurs were still diverse, still spread across many different ecosystems, and not a group already collapsing on a global scale. So the biggest question isn't just when the dinosaurs died out. It's what could possibly bring down an empire that had lasted for more than 170 million years? And that's where the real hunt for the culprit. In 1980, Luis Alvarez, Walter Alvarez, and their colleagues uncovered a hugely important clue right in the geological layer linked to the extinction. Many places around the world contained a sediment layer rich in iridium. That element is pretty rare in Earth's crust, but much more common in meteorites. So the discovery was basically science's way of saying, something from space hit this planet. Then, in the early 1990s, scientists found what felt like the smoking gun of the whole case: the Chicxulub crater beneath Mexico's Yucatan Peninsula, about 180 kilometers wide. The object that made it is thought to have been around 10 to 12 kilometers across. And honestly, just hearing those numbers already sounds bad, because an impact like that would have been powerful enough to trigger global earthquakes, enormous tsunamis, and blast huge amounts of material into the atmosphere. Try to picture a completely ordinary day at the end of the Cretaceous. Herds of plant-eating dinosaurs are still moving through the forests. Predators are still stalking their prey as usual, and the sky seems calm. Then a bright speck appears, and just seconds later, the whole planet shakes. But the deadliest part was not just the impact itself. Dust, soot, and sulfur-rich aerosols were blasted high into the atmosphere, blocking sunlight and creating what scientists call an impact winter. Photosynthesis collapsed, plants began to die off, herbivores lost their food source, and eventually even the top predators could no longer survive. According to many modern models, that chain reaction alone was enough to trigger the collapse of ecosystems on land and in the oceans on a global scale. That is why the Chicxulub impact hypothesis remains the strongest explanation for the dinosaurs' final downfall. The timing fits, the scale fits, the destruction was catastrophic, and the geological evidence is remarkably clear. If this case had only one suspect, things would be a lot easier, but science rarely makes it that simple. In recent years, an old name has come back in a pretty convincing way: the Deccan Traps, a massive basalt province in India, formed by huge lava eruptions near the end of the Cretaceous. Every major eruptive phase didn't just pour out lava, it also pumped huge amounts of CO2, SO2, and other gases into the atmosphere, enough to throw the global climate badly off balance. CO2 could warm the planet over the long term, while sulfur aerosols could cool it in the short term, trigger acid rain, and make the oceans more acidic. Some high-precision dating studies suggest that the biggest eruptions of the Deccan Traps happened very close to the KPG boundary, and that opens up a pretty reasonable possibility. Before the Chicxulub asteroid actually struck, Earth's ecosystems may already have been under serious stress from climate instability, disrupted oceans, and food chains that were becoming more fragile. Put simply, the Deccan Traps may not have delivered the final blow, but they could have been the slow burn that weakened the planet bit by bit. Then, when the asteroid arrived, that impact became the killing stroke. Did dinosaurs really disappear completely? If the answer is no, that sounds a little surprising, right? But it's true. The group that disappeared was the non-avian dinosaurs. Another branch survived, kept evolving, and is still all around us today, modern birds. Fossil evidence reveals a close connection between dinosaurs and birds, especially through Archaeopteryx, the oldest known bird fossil, dating back more than 150 million years. These ancient creatures carried traits of both dinosaurs and birds, from sharp teeth to feathers covering their bodies. Over time, they gradually evolved. Teeth disappeared, giving way to beaks, while flight became one of their most important tools for survival. But with such a close relationship to the dinosaurs that vanished from the Earth, why did birds manage to survive? The answer likely lies in a combination of several factors: their small size, their ability to eat many different kinds of food, and most importantly, their ability to fly. Through scientific evidence, we can begin to imagine the terrible catastrophe that happened 66 million years ago. Yet there is still so much we do not know. The end of the dinosaurs was not only the closing chapter of a glorious era, but also the beginning of a new one in the evolution of life on Earth. Could another species one day face a similar fate? And can we, as humans, learn from the past to better protect our planet? What do you think about this? Leave your thoughts in the comments below. And don't forget to follow Wiki Wonder to discover more fascinating stories about the world around us.